Hey, this is Mr. Alexander. Today I want to talk to you about problem solving with two-dimensional Venn diagrams, which is IB subtopic 3.7. So, if we have a Venn diagram, like this one where it says, Miss Snow conducted a survey of her homeroom. She asked students what math course and what science course they were taking this semester. Below are the results. Looks like 14 were taking Algebra 2 exclusively. 4 were taking Algebra 2 and Chemistry, 5 were taking Chemistry, and 6 were taking neither course. We're supposed to find the probability that a randomly chosen student is taking neither Algebra 2 nor Chemistry. Well, it looks like there's 6 of those kids, but the question is 6 out of what? Now, to figure out how many are in the universe, we'll say 14 plus 4 is 18 plus 5 is 23 plus 6 is 29. That would be 6 out of 29. Which as a decimal is 0.207 to 3 significant figures. To find the probability that a randomly chosen student is taking both Algebra 2 and Chemistry, well, that's the intersection. That's those 4 folks right there out of 29, which is 0.138 to 3 significant figures. That's just basic probability. The next one's what we call a conditional probability question. Find the probability that a randomly chosen student is taking chemistry given that they are taking Algebra 2. So whenever you see given that, it means we're going to limit our universe. Given that they are taking Algebra 2, we are only looking at the people who are taking Algebra 2. So these 18 folks right here, that's our new universe. Given that they're taking Algebra 2, what's the probability that they're taking chemistry? Well, of those 18, only 4 are taking chemistry. So it would be 4 out of 18, which is 0.222 to 3 significant figures. Some of these, you're not given the Venn diagram, and so you have to think a little bit harder. And so let's talk about one of those. Students survey 758 spectators at a national championship tennis match. The survey results indicate the following: 421 are male, 256 have a two-handed backswing, and 176 of the people with a two-handed backswing are female. We're supposed to draw a Venn diagram, so I'm just going to go ahead and draw the universe first off. And I happen to know that there are 758 people in the universe, so I'm going to indicate that right there. And I'm going to draw 2 circles. And the question is, what are the variables that are these circles? And I think the hint comes right here. 176 people with a two-handed backswing are female. So if we make this circle females, and we make this circle two-handed backswing, that means that the intersection is 176 right here. Well, if I know that 256 people have a two-handed backswing, well, I can do 256 minus 176 to figure out that 80 of those people with a two-handed backswing are male. Well, how many males are there total? There's 421 of them. So there's 80 of those males, leaving me with 341 remaining males. So 80 of them have a two-handed backswing. 341 of them do not. And of course, this 4 sectors here, they need to add up to 758. So if I do 758 minus 176 minus 80 minus 341, then I know that there are 161 females that do not have a two-handed backswing. If you've done this correctly, of course, all 4 of these sectors will add up to 758. The number in the universe, which does. So now we can use this Venn diagram we've drawn to start answering questions. What's the probability that a person selected at random from the group is male? Well, that'd be 421 out of 758. What's the probability that a person selected randomly from the group has a two-handed backswing? Well, there's 256 of those folks out of 758. What's the probability that a person selected randomly from the survey group is male or has a two-handed backswing? That word or means it's additive. We have to put them together. So male or they have a two-handed backswing, that's these three folks right here. So 176 plus 80 plus 341 plus 80 plus 341. It's going to be 597 out of the 758. Or means one or the other or both. The word and means both exclusively. Last question here. What is the probability that a person selected randomly from the survey group does not have a two-handed backswing, given that, there's that key phrase again, given that the person is male? So I'm only going to look at these males here, those 421 males. Given that they're a male, what's the probability that they do not have a two-handed backswing? Well, those 80 people do have a two-handed backswing. These 341 do not. So the probability is 341 out of the number of males, which is 421. All right, I've got time to do a few more of these. So let's go ahead and do this one as well. In a class of 29 students, 20 study French, 15 studied Malay, and 8 study both. Draw a Venn diagram. Again, I'm going to start with the universe, which I know to be 29 students. Some of them study French. Some of them study Malay. Some of them study neither. I know that 8 study both, so I'm going to go ahead and put 8 at the intersection. There's 20 who study French. I've already accounted for 8 of them. That means that there's 12 remaining. 15 study Malay. I've already accounted for 8 of them. That means 7 study Malay exclusively. This adds up to 27. There's supposed to be 29 in the universe. That means there's a 2 right there for the number of students who don't study either of those 2 languages. Now, we can answer these questions. What's the probability that a randomly chosen student studies French? Well, there's 20 of them out of the 29, which is just about 0.690 to 3 significant figures. Probability that they study neither would be 2 out of 29, which is just about 0.69 to 3 significant figures. Studies at least one language, that would be these folks, and these folks. That's 27 out of 29. Studies both languages, 8 out of 29. Probability that they study Malay, given that they study French. Well, given that they study French, there's 20 of those people. So it would be 8 study Malay, given that they study French. That's 8 out of 20. Probability that they study French, given that they study Malay, that's given that they study Malay, there's only 15 of those, and of those 15, 8 of them study French. So that's 8 out of 15 there. I want to do one more. We'll be done talking about Venn diagrams. The last thing that I've not yet talked about is question 6 here. And it's a formula that we haven't talked about yet. A group of 30 students were asked about their favorite topping for toast. 18 liked peanut butter, that's A, so I'm going to say A equals 18. 10 liked jam, that's B, so B equals 10. 6 liked neither, I'm going to put that 6 right there. And I happen to know the universe is equal to 30. Find the number of students who like both peanut butter and jam. Well, to do that, we need this formula that's on the IB formula chart. And the formula is as follows. The probability of A union B is equal to the probability of A plus the probability of B minus the intersection of A and B. Now, we happen to know all of these things except for the intersection. That's the number who both like peanut butter and jam. I know how many are in A. It's 18. I know how many are in B. That's 10. And I also know how many are in the union. If there's 30 overall, 6 of them like neither, 30 minus 6 is 24, must be inside these circles here. So 24 equals 28 minus the probability of A intersect B. When I subtract that 28, I'm going to have a negative 4, just divide both sides by negative, 4 is in the intersection here. So that's a 4, which would make that a 6 and that a 14. So find the probability that a randomly chosen student from the group likes peanut butter given that they like jam. Well, given that they like jam, there's 10 of those. And so it'd be 4 out of 10, which is 0.40 or 40%. Alright, that's all I've got for you today. Thank you for watching. Next time we'll do a video on 3-dimensional Venn diagrams.